In my experience in working with machining manufacturers, one of the main points to focus on is making sure that your concentration isn't too low. The reality is that you can make a good coolant go bad if you're not managing those concentrations. And if what happens if your concentration is too low, you can start to see rust, both on the machine tool and on the part. You can see degradation of the coolant from a biological standpoint because it's out of the recommended range that a manufacturer of metalworking fluids would recommend that concentration be in to be able to fight off any of that. You can also see degradation in your tool life, significantly at times, and that's a huge cost. And what happens is over time, if it's not checked, if it's gone out of check, you could run days like this. So the impact could be far greater than just trying to keep that concentration within the manufacturer's recommended specs, because ultimately if you end up losing the pH or the stability of the coolant, then you would actually have to change out that whole sump, which would be more costly than having to add back to the sump to just keep that in a regular concentration. So the second piece to concentration control with water dilutable or water-based coolants is making sure that that concentration isn't too high in range. The reality is that with water dilutable coolants, as concentrations rise, you can ultimately put your machine tool components at risk because the coolant could potentially be more aggressive to seals, more aggressive to hoses. It can also be a little bit more aggressive to an individual's skin or dermal irritation. The other piece is that you're ultimately, at some point, you're getting diminishing returns where you're actually using too much coolant. And ultimately, you could cut that back and still achieve the tool life that you want to at a concentration that's within the manufacturer's spec, but not waste coolant and actually reduce the amount of cost that you have in operating that. So one of the best things that you can do to be able to manage your concentrations properly is have someone take ownership of that responsibility. Someone knows whose job that is to take those concentrations. And you can either assign that to an operator, you can assign it to somebody in maintenance, whoever you want to assign to, but have someone do that. Because if you're checking your concentrations once a week or maybe every once in a while or infrequently, we don't know when the last frequency was of when that concentration was taken. And that could leave you susceptible to days or a week's worth of bad tool life that had been degraded because of that. So in order to keep concentrations, the best way to look at concentrations, the best way to know what your machine tool concentration is at is by utilization of a refractometer. You can either use an analog or a digital refractometer, but that tool, and really, like I said, it really takes 15 to 20 seconds just to quickly check, because your cutting fluid, it is a tool. It's an extension of your machine tool. It's an extension of your cutting tools. It is going to be what's protecting that part and ensuring that part quality. So why not make sure that that is in spec and that is within the range that it needs to be. One of the other pieces to that we can actually provide you is a concentration chart. And that's just a very, very easy tool that you can post on the side of your machine tool right by your sump, so that when someone takes a concentration, they just write it down. But that's a visual indicator that that job has been done and that you do know and are aware with where the concentration is and if something has been adjusted, if water had been added. So that way, when second shift comes in, they're more prepared to know that their concentration is going to be within spec, and they're confident that when they begin machining parts that they're going to be at the correct concentration.